At the start of the session today, in this introduction to digital electronics, we shall study the following contents, which are listed as follows. That those are the digital and analog quantities. We shall study what are digital quantities and analog quantity. We shall study the digital system, digital circuit, what analog and what is the difference between them, how is digital advantages or disadvantages than compared to analog, and all. Next we shall study about the binary digits. So what is the meaning of binary, how are they denoted, and we shall study also the logic levels and the digital waveforms. All this forms the basis of digital electronics. So building your basics strong will have you gain more knowledge on the subject, so it might be useful in further classes as well. Without much delay, let's start by taking the first topic. Let's see in the introduction we shall see that in the right corner we can see a analog signal and a digital signal. So what we think or what we are trying to study is the whatever we see in this electronics world, that is all the instruments, gadgets. These are divided into two streams, that these are the analog and digital. See, one can take an example of any analog devices and digital devices. Let's take an example of a thermometer, which is the mercury thermometer, and also we have the digital thermometer. So all this world of electronics is divided into two streams, mainly analog and digital. Now we shall see individually what analog and digital quantities are. So according to a definition, an analog quantity is one having continuous values. You can see in this figure that is the analog signal. You have some wave, which is a sinusoidal wave, which is continuous. So we define analog signal as a continuous, having a continuous values. Fine. Now next one is the digital quantity. In this we see that a digital quantity is one having a discrete set of values, that is discrete in the time, it is distinct and it is not continuous. So analog is opposite to digital. I mean these have a continuous value, whereas digital signal has a discrete set of values. These are basically called as analog and digital. But in the field of electronics we deal with lot circuits. So especially we shall now study what an analog circuit is. An analog circuits are those in which voltage and current vary continuously throughout some range. We have seen here in the analog quantity there is a continuous change of values. So in an analog circuit, an analog electronic circuit, there is a change between the voltage and the current which vary continuously throughout some specified ranges. Now what about digital circuits? Here the digital circuits are they have only two possible states that are typically represented by two voltage levels. Here we shall discuss this in detail in the next slides. Yes, now we shall see the analog signal and what do you mean by analog system in detail. Yes, see what we call an analog systems. These are capable of processing a continuous range of values varying with respect to time are called analog systems. Yes, let's see according to the definition. Consider this figure, which is figure 1b here. If we consider this as an analog system, now this system has the capability of processing a continuous range of values varying it with respect to time. We can see that it is varying with respect to time t. Now here the values the varying values are the voltages. The voltage variation can be plotted as per the time t, and as this is continuous we can represent it is in an analog form. Now this analog system, we studied about what is analog system. Now we shall find out its characteristics. That is, it is a system in which signals have infinite number of values. Yes, this is the main significance and the difference between the digital and analog. Here it states that it has an infinite number of values. Yes, that is, consider this figure 1.1. Here we know that there is a plotting of temperature up to 100-degree maximum, and they have given certain time a day in which the signals are plotted. I mean the temperature are noted down. Here why will we say it infinite? Because consider at the 11th hour it is around 92 temperature, 92 degree Fahrenheit it is. So as soon as it is continuous, at next second the values changes, that is both the temperature as well as time changes, so it is continuously changing, hence we call it as infinite. But it is contrary to the digital system, where we shall study the digital system in the next slide, so we may get the difference between the analog and digital. Now the third line states that the information varies continuously with time. Yes, we have known that the information varies with respect to the time. Now what does this analog system processes? They process time varying signals that can take on any value across a continuous range of voltage, current, or any physical parameter. So as per one analog system may be different from analog system, but usually here we have taken the temperature with respect to time, here we have taken voltage with respect to time. So this analog system, it uses the and processes the time varying signals. Now we shall see in detail the digital signal and digital system. Right. So what is digital system states that it is digital systems are those which process discrete values are called digital systems. Right. So we know that it is not continuous. The basic difference is there we have seen that the analog system is continuous, whereas here in digital system it is discrete. I mean it is distinct. How can we like understand it in very clear way? That is, now we can see what is digital signal. As a signal which can have only two distinct values is called a digital signal. Yes, we consider this figure, we can see here that it has only two distinct values, that is 0 volts and 5 volts. So a 0 volt is denoted by a 0, 5 volt is denoted by 1. So we can see in further why this 5 volts is denoted as 1, as well as 0 volt is denoted as 0. Here also we have taken the x-axis as time and the y-axis as voltage, same as in your previous sinusoidal wave also. Fine. Next, a signal which can have only two distinct values is called a digital signal. Yeah, we have seen that. The third statement says that it is a system in which signals have finite number of discrete values. Yes, what we saw in the analog was the information was very yes, in this system signals have infinite number of values, whereas in digital system it has finite number of values. We can see the same example over here. So we note that at the time 10 a.m. the temperature may be around 87 degrees. Fine. Now there is no 10 a.m. and 1 minute, because they have quantized it. I mean each hour has a particular temperature recorded in it. So this gives a finite number. So at this point we have a finite number, and this point we have a finite number. If it was analog, there would have been continuous change in the x-axis and y-axis, but here we have a discrete number, a discrete value which has been plotted upon. So what are the examples? Some examples are the electric impulses, decimal digits, and arithmetic operations. These all come under the digital signals and digital system. Now let's take up an example so that we know the actual difference between the analog and digital system. Yes, consider this figure, that is the figure 1 of 1 and the figure 1 of 2. Yes, in the figure 1 of 1, let us consider this. The air temperature changes over a continuous range of values. right? So during a given day, the temperature does not go like from 80 to 81 instantaneously. We can see that there is 80 to 85 transition between 80 to 85, but it does not go instantaneously. It takes on all the infinite values in between, as we told before. How it is infinite? Because both the x-axis and y-axis keeps on changing. Now if we graph or we plot a graph the temperature on a typical summer day, okay, now you can see that you would have a smooth and a continuous curve similar to the curve which we are seeing in the figure 1 of the one. Fine. Now consider the second figure, that is the figure 1 of 2. Here, rather than graphing the temperature on a continuous basis as we did in the first diagram, we shall just take a temperature reading every hour, that is at 1 am, 2 am, 3 am, 4 am, 5 am, etc. Now we have sampled values representing the temperature at a discrete point in time every hour over a 24 period. Correct? We have sampled values representing the temperature at discrete points in time over a 24 period. Discrete time alli ನಾವು ಏನು ಮಾಡಿರ್ತೀವಿ, temperature na at a particular hour we have been plotted it. So what we have usually basically done is we have just converted the analog system into a digital system. Here we can see the differences. The analog was continuous. Here we can see that the digital signal has been discrete. Here we had infinite values. Here we have finite values. Now in the next session we shall study the detailed difference between the digital and analog. Temperature sensors. It is an example of a analog device. However, other devices are the mercury thermometer, which we use during to measure the temperature, and the FM radio signals, the photocells, and the light sensors. These are the examples of the analog devices. ನೀವು ಇದರಿಂದ ಮುಂದೆ ಕೂಡ ಯಾವ್ಯಾವ ಅನಲಾಗ್ ಡಿವೈಸಸ್, ಡಿಜಿಟಲ್ ಡಿವೈಸಸ್ ನಿಮ್ಮ ಸುತ್ತಮುತ್ತ ಇರುತ್ತದೆಯೋ, ನೀವು ಯಾವುದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರೋ ಅದನ್ನೆಲ್ಲ ಕೂಡ ಲಿಸ್ಟ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕಾಗುತ್ತೆ. ಸೊ ಆನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಡಿಜಿಟಲ್ ಡಿವೈಸಸ್ ಆರ್ ದಿ ಕಂಪ್ಯೂಟರ್ಸ್, CDs, DVDs and the digital thermometer. In the next slide, now we saw the difference between analog and digital. So ಈಗ ನಾವು ಅನಲಾಗ್ ಇಂದ ಡಿಜಿಟಲ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ವಿ ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡಲ್ಲಿ. ನಾವು ಲೆಟ್ ಅಸ್ ಸಿ ವಾಟ್ ಈಸ್ ದ ಯೂಸ್ ಆಫ್ ಕನ್ವರ್ಟಿಂಗ್, or what is the actually the advantages of digital. So as we have listed here, the first one is it is easier to design. The digital electronic circuits or the digital devices have a easier to design approach. The second one is the information storage is easy. For example, consider music. When a music is converted to digital form, it can be stored more compactly and reproduced with greater accuracy and clarity than is possible when it is in analog form. Right? And the third one is accuracy and precision are greater compared to analogs. Fourth one is that the digital circuits are less affected by noise, as long as the noise is not large enough to prevent us from distinguishing high and low. We shall study in detail what are these high and low. The fifth one is the digital data can be processed and transmitted more efficiently and reliably. The faster the communication technology which we are using now has the digital approach in it. So we have seen and we have observed it, how the transmission is and more efficient and it is more reliable than the age-old analog signals. Now let us study what is binary digits. So in digital electronics, the digital electronics involves circuits and systems in which there are only two possible states. We have seen it in previous slides also, that is the digital signals are represented only in two states. Fine. So these states are represented by two different voltages, that is a high and a low. That is, a digital electronic circuit has two possible states, that is, one is high and one is low. So the two state number system is called as binary. We know that bi, it means two. So the digital electronic circuit uses only two systems, that is a high and a low, hence this it is called a binary. And what are those two digits? It is a 0 and 1. So, and single bit or a single digit in a binary is called as a bit. A binary digit is called a bit. Now let's see, typically the binary 0 and 1 are represented by two nominal voltage levels. We represent it as 0 and 1. Now combining all the three statements, we can come to a conclusion that we present 0 for low, that is, we represent a state of bit 0 bit for low in terms of voltage. If we want to represent a 0 voltage, we give it as low, which is 0. Similarly, 1 is given by high. In the terms of voltage, it is 5 volts. That is, we want to represent it 5 volts, we give it as a high. It is represented by a high state and it is denoted by a bit 1. So in a binary system, we have only 0 and 1, and in binary digits are 0 and 1. So a binary means two digits, that is 0 and 1. So all the operations which the electronic circuit in digital form operates basics on this 0 and 1. You might be aware of this previously also. Now going forward, there is something called as positive logic and negative logic. See this figure 3. Here we know that 0 and 5 voltage are plotted. Now we can see that there is a bit 1 or the high, so it represents 5 volts. A bit 0 represent 0 volts, that is a low state, and again there is 1 and 1, so it is represented at 1 0 1 1. So what is a positive logic? Positive logic is that the high state is represented by a bit 1 and the low state is represented by a bit 0. Then coming to the negative logic, here the opposite or the contrary of the positive logic is called as the negative logic. Here we can tell that the high or 1 represent the lower voltage level, right? If it is 5 volts, it is the high state is represented by a 0 and the low state is represented by a 1. But in the most of the cases and most of our study goes on with the positive logic. We just take on the positive logic further. Fine. Now let's see what is logic levels. In the logic levels, the voltages used to represent a 1 and a 0 are called logic levels. Now we saw in the previous diagram that we add 0 to 5 volt. We have taken this simple diagram to explain it. That is, in figure 1.6 we know that there is a VL minimum, VL max, VH minimum and VH max. What are these? So we know that here high is represented by binary 1 and a low is represented by a binary 0. So we may feel that in an analog circuit it was sine wave, so it was continuous. So we might feel here that ನಮಗೆ ಇಲ್ಲಿ ಅನಿಸ್ಬೋದು ಏನು ಅಂತ. ಸೊ ಅನಲಾಗ್ ಸಿಗ್ನಲ್ ನಮಗೆ ಹೇಗಿರ್ತಾ ಇತ್ತು, ಸೊ ನಮಗೆ ವೇರಿಯೇಷನ್ ಗೊತ್ತಾಗ್ತಿತ್ತು. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಅಟ್ ಒಂದೇ ಟೈಮಲ್ಲಿ ನಮಗೆ ಹೈ ತೋರಿಸುತ್ತೆ ಆ್ಯಂಡ್ ಒನ್ ಟೈಮಲ್ಲಿ ಲೋ ತೋರಿಸುತ್ತೆ. ಸೊ ಹೌ ಇಸ್ ದಿಸ್ ಪಾಸಿಬಲ್, ಹೌ ದಿಸ್ ಅನಲಾಗ್ ಸಿಗ್ನಲ್ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಡಿಜಿಟಲ್ ಅಂತ ನಾವು ನೋಡೋದಾದರೆ, ನಾವು ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್. ಹಿಯರ್ ಹೇಗೆ ಈ ಥರ ರೆಪ್ರೆಸೆಂಟ್ ಆಗುತ್ತೆ ಅಂದರೆ, ಲೆಟ್ ಅಸ್ see there is ideally one voltage level represents a high and another voltage represents a low. Ideal condition. So 0 iddaga it represents low, when it is 5 volts it represents high. We have seen this in the before slide also. But what happens is, in practical digital circuits, a high can be any voltage between a specified minimum value and a specified maximum value. ಸೊ ಯು ನೋ ದಟ್ ಯಾವತ್ತೂ ನಮಗೆ ಐಡಿಯಲ್ ಸರ್ಕ್ಯೂಟ್ಸ್ ಇರಲ್ಲ. ಸೊ ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ನಾವು ತೊಗೊಂಡಾಗ ಏನಾಗುತ್ತೆ, ನಮಗಿಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಲೈಕ್ ಇದು 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ 1 2 3 4 ಆ್ಯಂಡ್ 5 ರೈಟ್. ಹಾಗೆ ಲೈಕ್ವೈಸ್ a low can be any voltage specified between a minimum and a specified maximum. ಹೌದಲ್ವಾ? ಸೊ ಯಾವುದೋ ಒಂದು ಮಿನಿಮಮ್ ಇರುತ್ತೆ, ನಾವು ಇದನ್ನು 0 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಸೊ ಲೆಟ್ ಕನ್ಸಿಡರ್ ಇಟ್ 0 ಆ್ಯಂಡ್ ಲೆಟ್ ಅಸ್ ಕನ್ಸಿಡರ್ ಇಟ್ ಆ್ಯಸ್ ಅ 5. ಸೊ ನಮ್ಗೆ ಯಾವುದೋ ಒಂದು ಮಿನಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ, ಅದ್ರ ಮೇಲೆ ನಮಗೆ ರೀಚ್ ಆದರೆ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆ್ಯಸ್ ಅ ಹೈ. ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಲೋಗೆ ಒಂದು ಮಿನಿಮಮ್ ಆ್ಯಂಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ. ಸೊ ಇದನ್ನೇ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ ಅಂದರೆ, figure here, the figure 1.6. See what does it illustrates is the general range of lows and highs for a digital circuit. ಅಂದರೆ ಒಂದು ಜನರಲ್ ರೇಂಜ್ ಇದೆ, ಸೊ ಅದನ್ನು ಇದು ಸ್ಪೆಸಿಫೈ ಮಾಡುತ್ತೆ. ಇಲ್ಲಿ ನೋಡ್ಬೋದು ನೀವು, ದಿ ವೇರಿಯೇಬಲ್ VH max represents the maximum high voltage value and the VH minimum represent the minimum high voltage value. ಹೌದಲ್ವಾ? ನೆಕ್ಸ್ಟ್ ನೋಡ್ಬೋದು ನೀವು, ದಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಲೋ ವೋಲ್ಟೇಜ್ ವ್ಯಾಲ್ಯೂ ಈಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ VL max and the minimum low voltage is represented by VL minimum. So the voltage in between the Vx max and the VH minimum, we call it as unacceptable for proper operations. We see that a voltage in the unacceptable range can appear either as a high. So ಈ ರೇಂಜಲ್ಲಿ it can appear either as a high or either as a low. It depends on circuits. It difference between it also has it is difference between the one circuit to another circuit. Now giving it to numerical terms, now observe this or write on. See, for an example, now we consider the high input values varies for a certain type of digital circuit. We will see it as it may vary from, high input may vary from 2 to 3.3 volts and low input may range from 0 to 0.8 volts. Understood? Now if a voltage of 2.5 volts is applied, where it will be the circuit will accept it as 1. We know that the high is 2 to 3.3 volts. ಅಂದರೆ 2 to 3.3 volts ಏನಿದೆ, ಇದು ನಮ್ಮ ಹೈಯಲ್ಲಿರೋ ರೇಂಜ್. ಆ್ಯಂಡ್ 0 to 0.8 ಏನಿದೆ, ಇದು ಲೋ ಲೆವೆಲ್ ರೇಂಜ್. ಸೊ ನಾವು ಒಂದು ವೋಲ್ಟೇಜ್ ದಟ್ ಈಸ್ 2.5 voltage is applied, it will be denoted by a binary digit 1, that is high. Now if a voltage of 0.5 is applied, what will happen? The circuit will accept it as a low or a binary 0. For this type of circuit, voltages between the 0.8 volts and 2 volts, this region is called as unacceptable. Fine. Now let us study the digital waveform. What this digital waveform is? A digital waveform consists of a voltage level that are changing back and forth. These are the voltage level which has been changing back and forth from high to low. We know that the digital circuits has only two representation, right? So what digital waveforms andre eno, illi voltage levels keeps on changing between the high and low. Illi kuda navu we can see that there is a positive going pulse and a negative going pulse. Now consider this figure 1.7. It shows that yes, a signal positive going pulse. Fine. Now a positive going pulse is generated how? When the voltage or a current goes from its normal low level to its high level. ಇದನ್ನು ನಾವು ಪಾಸಿಟಿವ್ ಗೋಯಿಂಗ್ ಪಲ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅದೇನು, ಲೋ ಲೆವೆಲಿಂದ ಹೈ ಲೆವೆಲ್ಗೆ ಹೋದಾಗ. ಆ್ಯಂಡ್ ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು high level to low level. Now ಈಗ ನೆಗೆಟಿವ್ ಗೋಯಿಂಗ್ ಪಲ್ಸ್ ಅಂದರೆ ಏನು ಹೇಳ್ತೀವಿ? We can see this in the figure B. Is generated when the voltage goes from normally high to low level and back to high level. This is called as the negative going pulse. Now this digital waveform, usually they are made up of many components. Now let us see here that as indicated in the figure, ಇದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಪಲ್ಸಸ್ ಅಂತ ಕರಿತೀವಿ. ಫೈನ್. ಸೊ ಈಗ we see that the difference between this and this diagram, what it denotes is figure 1.7 denotes a ideal pulse, whereas figure 1.8 denotes the non-ideal pulse. So while we were studying, ಸೊ ನಮಗೆ ಕೂಡ ಒಂದು ಡೌಟ್ ಬರ್ಬೋದು, ಅದು ಹೇಗೆ 0 to ಹೈ ಅದು ಸಡನ್ನಾಗಿ ಆಗುತ್ತೆ, ಆರ್ ಹೈ ಟು ಲೋ ಸಡನ್ನಾಗಿ ಆಗುತ್ತೆ. ಸೊ ನಾವು ರಿಯಲ್ ಡಿಜಿಟಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ಸ್ ಹೀಗೆ ಇರುತ್ತಾ, ಈ ಥರ ಡೌಟ್ ಎಲ್ಲ ಬರುತ್ತೆ. ಸೊ ಈಗ ಲೆಟ್ ಅಸ್ ಸ್ಟಡಿ this waveform. Here we can see that the pulses are ideal because, ಯಾಕೆ ಇದನ್ನು ಐಡಿಯಲ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂದರೆ, ದಿ ರೈಸಿಂಗ್ ಆ್ಯಂಡ್ ದಿ ಫಾಲಿಂಗ್ ಎಡ್ಜಸ್ ಆರ್ ಅಸ್ಯೂಮ್ ಟು ಚೇಂಜ್ ಇನ್ 0 ಟೈಮ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ಲಿ. ನಾವೇನು ಅನ್ಕೋತೀವಿ, ಹೈ ಆಯಿತು ಲೋ ಆಯಿತು, ಬಟ್ ನಾವು ಈ ಟೈಮ್ನ ಏನು ಮಾಡ್ಕೋತೀವಿ, ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಗಿದ್ದು 0 ಅಂತಲೇ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಬಿಡ್ತೀವಿ. ಅಂದರೆ ನಾವು ಯಾಕೆ ಇದನ್ನು ಐಡಿಯಲ್ ಅಂತ ಹೇಳ್ತೀವಿ ಅಂದರೆ, ಬಿಕಾಸ್ ದಿ ರೈಸಿಂಗ್ ಆ್ಯಂಡ್ ದಿ ಫಾಲಿಂಗ್ ಎಡ್ಜಸ್ ಆರ್ ಅಸ್ಯೂಮ್ ಟು ಚೇಂಜ್ ಇನ್ 0 ಟೈಮ್. ಅಂದರೆ ಗೊತ್ತು ನಮಗೆ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ ಆಗಿ ಹೈ ಟು ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ ಅಂತ. ಬಟ್ ಪ್ರಾಕ್ಟೀಸಲ್ಲಿ ಇದೇ ಥರ ಆಗುತ್ತಾ? ಟೈಮ್ ಟಿ ಇತ್ತು, T1ನಲ್ಲಿ ಅದು ಟೈಮ್ T0 ಹೈ ಆಗಿದೆ, ಟೈಮ್ T1ನಲ್ಲಿ ಲೋ ಆಗಿದೆ. ಬಟ್ ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ಹೀಗಿರಲ್ಲ. ಏನಾಗಿರುತ್ತೆ, ಇನ್ ಪ್ರಾಕ್ಟೀಸ್ ದಿ ಟ್ರಾನ್ಸಿಷನ್ ನೆವರ್ ಅಕ್ಕರ್ ಇನ್ಸ್ಟಂಟೇನಿಯಸ್ಲಿ. ಆಲ್ದೋ ಮೋಸ್ಟ್ ಡಿಜಿಟಲ್ ವರ್ಕ್ ಯು ಕ್ಯಾನ್ ಅಸ್ಯೂಮ್ ದಿ ಐಡಿಯಲ್ ಪಲ್ಸಸ್ ಡಿಜಿಟಲ್ ಇದ್ದರೂ ಕೂಡ ನಮಗೆ ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ಈ ಥರ ಪಲ್ಸಸ್ ಇರುತ್ತೆ. Now in this figure 1.8, this represents a non-ideal pulse. In reality ಏನಾಗುತ್ತೆ, all pulses exhibit some or all of these characteristics. ಹೌದಲ್ವಾ? ಬೇಸ್ ಲೈನ್ ಇರ್ಬೋದು, ಆಂಪ್ಲಿಟ್ಯೂಡ್, ಓವರ್ಶೂಟಿಂಗ್, ರಿಂಗಿಂಗ್, ಡ್ರೂಪ್, ಪಲ್ಸ್ ವಿಡ್ತ್, ರಿಂಗಿಂಗ್ ಆ್ಯಂಡ್ ಅಂಡರ್ಶೂಟ್. ಸೊ ಇಲ್ಲಿ ನಾವು ಇದು ನಮ್ಮ ಸಿಲೆಬಸ್ಗೆ ತುಂಬ ಯೂಸ್ಫುಲ್ ಆಗಲ್ಲ. ಸೊ ವಿ ಶಲ್ ಜಸ್ಟ್ ಸಿ ದಟ್ ದಿ ಡಿಫ್ರೆನ್ಸ್, ದಟ್ ಈಸ್ ಡಿಜಿಟಲ್ ವೇವ್ ಫಾರ್ಮ್ ಐಡಿಯಲ್ ಆಗಿ ಈ ಥರ ಇದ್ದರೆ, ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗಿ ಈ ಥರ ಇರುತ್ತೆ. ದಿಸ್ ಮೈಟ್ ಬಿ ಸಮ್ ಕೆಪಾಸಿಟಿವ್ ಆರ್ ಇಂಡಕ್ಟಿವ್ ಎಫೆಕ್ಟ್ಸ್ ಅಲ್ವಾ? ಸೊ ಓವರ್ಶೂಟ್ ಯೂಶ್ವಲಿ ಏನಾಗುತ್ತೆ, ಈ ಓವರ್ಶೂಟ್ ಅಂತ ಏನು ಹೇಳ್ತೀವಿ, ಇಟ್ ಈಸ್ ಯೂಶ್ವಲಿ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಇಂಡಕ್ಟಿವ್ ಆ್ಯಂಡ್ ಕೆಪಾಸಿಟಿವ್ ಎಫೆಕ್ಟ್ಸ್. ಇದು ನಿಮ್ಮ ಸರ್ಕ್ಯೂಟ್ಸಲ್ಲಿ ಇದ್ದೇ ಇರುತ್ತೆ, ಹೌದಲ್ವಾ? ಸೊ ಈಗ 5 volts ವೆನ್ ಇಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ 0 ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ 5 volts, if it exceeds it is called as overshoots, and when it is pulsating it is called as ringing, when it declines it is called as droop. So let us not take this into much depth. Fine, thank you.